All right, so in order to be accepted into a certain top university, applicants must score within the top 5% on the SAT exam. Given that the exam has a mean of 100, so let's write that, mean equals 1,000 rather, and standard deviation, S dot D, is 200. What is the lowest possible score a student needs to qualify for acceptance into the university? So this is gives us the mean, standard deviation. I'm assuming this is normally distributed. We're talking about SAT scores. There's my mean in the center. So in the terms of this problem, this mean is 1,000, and each standard deviation is 200, right? So it goes up to 1,200, 1,400, and then one more, 1,600. And then below the mean, it goes to 800, 600, 400. Now this is a general normal distribution for this problem, but doesn't exactly apply here because we're just talking about the top 5% of students. So I'm going to draw another normal distribution here. And we're interested in the top 5% here. So this is 5%. Or if I wrote this as a decimal, divide by 100, 0.05. So the area of this region here is 0.05. The area of this region here is 0.05, right? So what I can do is, just like the problems before, I know this area, so I can attempt to determine this z-score that gives this area, the z-score that yields this area. And then once I find that z-score, then I convert it back to real life numbers, convert it back to an x value, and that'll be the score that a student needs to qualify. So using this 5%, I'm going to find the z and then convert it back to an x value that would lie on this normal distribution here. So this area is to the right, right? This area is to the right of my z value, to the right, to the right, to the right. So I can think of, since the table always gives me, the table is going to give me this area to the left, I can subtract 0.05 from 1, and this area here would be 0.95. All right? So this area, the area that the table is going to give me, 0.95. So let's go to the table and attempt to find as close to 0.95 as possible, so we'll know this z value. Okay, I've already got my normal distribution table. 0.95, that z is definitely going to be a positive, so let's go for 0.95. 0.95. Oh, it's right in between these two. 0.9495 and 0.9505. 0.95 is literally right in between. So I will use the z that has a larger absolute value, the larger value. So 1.64 or 1.65. I'm going to use the larger one, 1.65. Right? So let's go back. So this z value, I'm going to erase this question mark because now we have an idea of what it is. 1.65. So this is the z value that yields 95% area on the left or 5% on the right. So the top 5%, they have a z-score of 1.65. But that's the problem, is not asking for the z-score. It's asking for the actual score back in real terms. So that's what I need to find out. I'm going to use my z formula. Z equals the value minus the mean divided by the standard deviation. So in this case, oh, let me erase that. So in this case, we know the z value, we know the z-score, right? We know that's 1.65. I don't know the value. That's what I'm trying to determine. I'm trying to determine what that x value is that gives me that 1.65 z-score, or gives me that 0.05 to the right. Minus the mean, which is 1,000, we have that. Divided by the standard deviation, which is 200, we have that. Okay, so essentially what we're doing is we need to solve this equation. I'm going to cross multiply. X minus 100 equals 200 times 1.65. So 200 times 1.65, we can do that in a calculator if you want. 200 times 1.65, that's 330. And this actually should be 1,000, x minus 1,000. I wrote 100 by mistake. Right. So then I add 1,000. So x equals 1,330. This is the score that this is the x value that yields a z-score of 1.65. That gives us that area 0.05 to the right. So if I'm going back on this just to show it here, we're somewhere around here. Somewhere around there. Gives you the top 5%. So if you have a score of 1330 or above, that's the minimum score you need for acceptance into the university. 1330.